Welcome to the electronicsHobbyblog.com. Today we're going to continue our resistor substitution box with part 4, wiring up the switches. Now I've already gotten a head start on that, and this is what we're going to end up with when we're done. We'll end up with 6 of these, one for each of our resistor scales, so a 1 ohm, a 10 ohm, a 100 ohm, and so on. So we'll go through and look at how we wire this up step by step. Hey there, we're going to start assembling the first switch. So I've mounted the switch in a little vise to hold it in place. Now there's a wire that goes on the center post, and it's going to be very difficult to put that wire on once the resistors are around it and forming a cage. So I'm going to cut that first. So I've got a roll of 18 gauge stranded wire. And this is going to be longer than we need, but I don't want to have to try to put a different one on later. So I'm cutting a piece about 8 inches long. And then I'm going to strip about 1/4 inch off the end using my using my strippers. So this has a spot for 18. There. Soldering iron's all hooked up, set to about 350 degrees. And I'm going to put a small hook in this. Actually, you know what? Just going to put it up here. Put it up here. And I want to just tin it a little bit first. It'll make it much easier to bend. So hopefully this is on camera, but I'm just tinning that piece of wire. Now that that's tinned, I'm gonna use my needle nose pliers, and this 18 gauge is pretty thick, so by the time you put the solder on, it's pretty tough to bend. Then I'm gonna bend it that way. So I don't know if you can see that, basically. Here, I'll show you different angles. And I'm going to use that and take that and clamp it onto here. And then I'm going to clamp that down tight so I get a good mechanical connection, and then the solder will give us a good electrical connection. This way, be less likely to move around and have a broken solder joint. So I'm going to put my iron in here and melt some solder on that. I don't want to leave it on too long because I don't want to damage the switch. It's plenty good enough. I'm going to let that solder joint cool for a second. Ah, nice. And now we're ready for the first resistor. I like to start at position 1, which is this one here. And I'm going to move this around a little bit, but I will do my best to keep it in frame. In fact, I'll check. Oh. Yep. It's in frame. Okay, so the next thing we're going to do is get a resistor. And I already did the one for the 1 ohms just to test it and make sure I knew exactly how I wanted to do it. But I'm going to pull out the 10 ohms. That's 100, 10. So here are my 10 10-ohm resistors. These are going to look a little different than the ones that I recommended that you purchase. And the reason for that is that I chose to spend a little bit more money and go with 0.1% resistors. 0.1% 3 watt. And I was able to do that for all of them except the 1 ohm resistors, which were prohibitively expensive in a 0.1% tolerance. I did get them in a 0.5% tolerance. So here it is with the leads, and I'm going to take one of the leads here and I'm going to bend it to the side. So I've made it an L. And then I'm going to take it and I'm going to make a loop in my L. Make a loop like that. And then cut it off with my diagonal cutters. So I don't know if you can see that. See, there's a loop there and there. And I'm going to take this and I'm going to put it on. Cut a little more of that off. I'm going to put it on the pin so that it's facing almost straight out. And I'm going to, again, form a mechanical connection by squeezing. So you can see how I've got that on the pin. I may have to move this around a little bit to get to it with solder, but that's all right. And I'm going to apply a little bit of solder. And then once it takes, I'll adjust it so that the resistor is straight up and down. I'm going to put a little more solder on there so we get make sure we have a good connection. Hold it in place. So there we go. I'll move this around so you can see it better. But I don't know if you can see that. So the resistor is sticking almost straight out from the switch, almost perpendicular, which is what we want, because we're going to take this lead now and we're going to bend this lead so it goes behind the resistor and comes down next to, we don't want it too close to that, down there. And then I'm going to snip it. You can see this from the back, I hope. You'll see it on the next one if not. And my fingers have to get in the way, sorry folks. But I'll show you when I'm done. I'm just bending that around the post. And from the other one that I did, what I found works best is if you keep this part up toward the top of the post. The reason is, there we go. The reason is that we can take the other resistor and put it down on the bottom of the post as we're doing this. You'll see that in a second. But what I want to do is make sure that the switches are not higher in terms of the distance from the top of the switch where it's going to push against the bottom of the case to the bottom of the resistor. And the reason for that is that we don't want, there we go. So I'll make sure that's still in frame here. Yeah. And I'll zoom in a little bit so you can see what I've done. See that? I went around the back of the resistor with that second wire. Let's see, how are we? Good. Let's come up a little bit. There we go. And before I solder that second connection, I'm going to do the exact same thing. I'm going to take another resistor, make a right angle, then I'll take that and I'll loop it, cut it, we end up with that. And that, sorry, that I'm going to put underneath this lead, and some of these are a little tricky because of these little plastic nubs on the bottom of the, and I'm going to squeeze that down to get a mechanical connection. And again, I want the resistor sticking almost straight out from the switch so it doesn't interfere with anything. And now I'll get behind that and solder that from behind here. And that's the second resistor. And so again, going to come down behind to here. Cut it away. And I can't work that way. I got to turn this. try and do another one from a different angle. And then again, I'm going to, whoops. And what I'm trying to do is I'm trying to take it easy on the switch pins because I don't want the switch pins breaking. And this, I'm going to take a little more off. There. That's good. This one's twisting. Perfect. Next resistor. Don't want that to cause a short. And again, same thing. Make the L. Create the loop. Cut it off. Underneath the last resistor. And I want to get these down as low as I can on the switch pin. Again, I want to minimize the distance from here to here because we don't want it to impact the back of the box or touch the back of the box, which is metal. So that one, and now this one. There we go, and then bend the pin down and cut. You get better at it as you go. It's pretty tedious though, so I'm not going to do them all in one day. And you got to sometimes work it around till you get it connected exactly the way you want it. And like I said, you want to be careful not to manhandle it too much because you don't want to damage the pins from the switch. There. That'll work just fine. Now we straighten my resistors a little. Next one going on. Again, it's the same procedure. Bend. Make the loop. Cut it. Go under. Squeeze to get a good mechanical connection. And solder. Okay. All right, I'm going to try turning this around or moving the camera to give you a different view. Okay, so from this angle you can see the back of the switch a little better, and I'll try to keep my fat hands out of the way. I want that straight up and down. And I'm going to bend this back. Again, we want it to come behind the switch, and we want to be careful of this other wire here. So we don't want to impact that. So I can twist it just a little bit without damaging it. And then we're going to come down here. And again, here. There we go. And you know, if you don't get it really, really tight, that's okay, as long as you get a good solder joint. Better that we don't have a short and we don't damage the switch. And these are very, very difficult to bend around like that and get the loop correct. It just takes practice. And I don't think I'll be able to do more than 2 of these in a day and not drive myself crazy. There we go. 4 on, 5 more to go. So again, probably driving you crazy showing you the loop too many times, but that's all right. Again, that plastic nub is a pain. All right, there we go. And again, remember, we want it sticking out from the switch almost perpendicular, like that. That'll give us more space. Less chance of pushing 2 wires together. Good. All right, so I'm going to go ahead and finish this. Bend this one down. Just kind of twisting it around as best I can. There we go. 10 ohm. 5 down, 4 to go. There we go. No, it's not going to interfere, especially when I come back this way a little bit. Okay. Don't like that. Solder this one first so it doesn't come off. Okay. This one. Little squirrely working in the tight space. There we go. Yeah, good separation. Don't have to worry about that. 3 more to go. All right, there we go. This one I let stick out a little bit more because of the nub. Okay. This one's looping a little easier. There we go. Next one. Again, and you can keep these in as tight as you can. I just am having trouble working that tight in because of the little plastic pieces that stick out. Go. Now we'll get this in. You can imagine if you were doing this with 1-watt resistors or half-watt resistors, they'd be quite a bit smaller. And the other advantage is that the leads would be thinner. It'd be much easier to form these loops in situ. There we go. Guess what? Last one for this switch. I'll form the loop. This one should be easy. There's no little plastic nub there. You could actually go to the other one to make it easier and come over, but keep it all consistent. Remember, heat then solder. And remove the solder and then remove the heat. And let the solder cool before you move anything, or you'll end up with a cold solder joint. And those resistors do get hot. Okay. Last one, get this loop around here. Okay, that's it. Okay. Okay, so you should have a good view of the ohm meter here. And I'm going to hook this up. I've got it set to the 0 position, so it should come up with 0 ohms right off the bat. And I want to be careful not to manhandle this. So the 0.037 that we're seeing is probably just wire resistance, wire and switch. So let's see what happens when we change it. So that should be, yep, 10.037, 10.038. It should be 20, 20.039. Dang, these are good. 30.035, 4, 40, just going through each position. 50, 60, 70, there's 80, one more, 90. We'll go back to 0. So that little bit of resistance we're seeing at 0 is probably due to the wires. And you'll see, I'm going to get rid of those. We're going to keep these wires. When we actually put this together, we're going to do our best to keep these wires. You notice it went down quite a bit. That's why we're using big wire, and we're going to do our best to keep the wires as short as possible.